Well, hi, and thanks for joining me in my shop here. And I'm going to continue working on this Philips 922, and I believe this would be video number 17, I think. And what I'm going to be doing today is aligning the radio, finishing the alignment on the radio. What I've been struggling with this radio, if you've been watching the previous videos, you know there's a funny crackly sound coming out of something going on in this radio. I have not been able to nail it down. I have some good suggestions from some of you about what it might be, including these large capacitors, which I've still left in at this point. And another problem that came up was this hum that appeared kind of from nowhere, clearly related to the grounding of my shop equipment onto the chassis of the radio. And last night, frankly, I sat down to do a video where I would explore this hum and try to understand where it's coming from and what causes it, and try to get a really good grip on it, because it is really driving me kind of nuts. Set up the radio, all the equipment, I started videoing, and I could not recreate the hum no matter what I did, which has just left me even more lost as to exactly what is going on with this radio when it comes to this hum. So I'm going to put it out of my mind. I'm going to put the clicking, popping, crackling out of my mind too, and I'm just going to carry on with the alignment. Sometimes this radio appears to be working just fine. It's loud, it's receiving on all bands, it seems just fine. And then at other times it seems to lose its output. And frankly, I have not been careful enough in how I've applied signals and how I've tested this radio to know for sure what is causing these things. So there's still lots of question marks floating around, and I don't seem to be able to get rid of some of them. So I've decided to not, at this point anyway, carry on with troubleshooting, because frankly it's getting me nowhere. I'm just going to go back to aligning the set, and while I'm doing that, of course, we'll be playing the set, and we'll hear if some more of these unfortunate effects reappear. So that's what's going on today in my video. So the first thing we're going to do is turn this guy on after I give him a quick safety check. Yeah. Okay, now just keep your eye on my voltmeter here. It's reading 132 volts right now, which is probably reading a little high. It's probably more like 128, still pretty high. And my voltmeter tends to relax a little bit after it's run for 15-20 seconds, so I'll let that happen. So we're running around 130 volts on the plug on this. Open circuit, I don't have the radio on. When I turn the radio on, that supply voltage is going to drop way down, as you've seen many times. During the rush of current, goes into the heaters while they're cold, so you'll see this, it'll pull the voltage way down. The voltage will climb back up as the heaters heat up and draw less current. And once they're fully hot, the plate currents begin to flow, and you'll see that voltage drop again. You say, well, wait a minute. My radio is drawing down the voltage of the power system in my city. No, I have a light bulb in series with the radio. And again, if you've been watching my videos, you know this. The light bulb's located back here. That's actually the sound of it. And that's how I prevent a huge inrush of current, or really a short circuit in the radio, which if you just plug it in the wall, turn it on with a short circuit, something's not going to last long. Put a light bulb in series and the light bulb will just glow very, very bright, and you have lots of time to avoid some other conflagration from happening. So, okay, so let's turn it on and watch this meter again. You'll see it go down, come back up, and go down, and as it goes down, the radio should come to life. There we go. There it goes down. There it comes back up. So those are the heaters heating up, drawing less current. It's fully hot. The heater has to heat the cathode, which is a sleeve around the heater. Takes a little more time. There it comes.
Stop and go out past the Allen. The southbound 404 Parkway is busy still down towards the 407. And again, as you head over the 401.
You're hearing a new problem. Okay, that just showed up last night when I was performing my test that didn't work, my hum test. The radio began to have complete interruptions in it. You can hear them. There's a good one right there. So is it more of the same? Or is it something new? Oh my god. Well, we'll let it play here for a second. So that's an interruption right in the output, I believe. It seems to, it's actually a high and a low, like it's a high volume, low volume situation. So that could be the thing that's been changing slowly, almost imperceptibly, and now it's changing rapidly. We can hear it. Let's see, the volume's coming up now. I can't do an alignment like this. I just can't. It's just stupid to even try. And the output at least has to, it can be noisy, but the output has to be steady. More clicking around here. Kind of a useless exercise, I find, but you ever wonder how things get broken in a radio? This might be one way. Nothing. Nothing at all. Well, let's see. That variation in volume, oh my god, that could be almost anything. Could be a capacitor, a resistor, could be a tube. Listen to it. Could be the volume control, which I don't think it is. Maybe it's the tone control. Can't imagine how that would be. Okay, well let's see if we can catch what it is that's changing. Maybe by monitoring voltages or something like that. 1010, that's a powerful local AM station. Should come in and clear as a bell here, and you can hear that. It's not so clear, but then we're down in my shop here, so... Okay, so what do we want to read? You want to read the chassis? We can't. We can't read DC voltages to the chassis. The chassis is isolated by capacitors, one in particular. So we'll clip on to the B- point in the radio, or more commonly just called the ground. I might like to call it the neutral or 0 point myself. Listen to that, eh? That's what I gotta hunt down. Okay, let's go on to B+ first. Should be watching this meter here. Okay, that's about 100 volts. What's the problem there? That's about 125 volts. And this last section is just a few volts. So this last section may be the bypass capacitor for the output. In fact, I can see a wire going from here right down to the output tube. So this last section is just the maybe the voltage across the cathode resistor. It's probably this resistor right here. Oh wait a minute, there's another terminal here. I guess I'd have to study the schematic a little bit to figure that out, but we're chasing nothing here. So let's so we'll look at the output, and we'll just look for a jumpy voltage. So I'm keeping your eye on this meter here. Something that jumps with the sound we're hearing. Okay, so here's the preamp for the audio section. This is the AT6, the 12 AT6. So it's not doing the, you know, like the output's not going dead so much anymore. In fact, it's not going dead at all, is it? And that stopped after I worked this tone control. What a... just... This radio, like, you start chasing a problem, and while you're chasing it, the problem just kind of goes away and changes its nature. So we got the noise problem. It's not evident right now. Got the variation in the strength, which is evident right now. Right now it just went up and down. And then we have this hum thing, which I think is a not an important thing anyway. It's just a phenomenon of how I had it in my shop. I don't really know what that is. What's number 4? I think there's even a number 4. I'll reserve number 4. Wow. I'm just waiting for something to happen here. You better not touch it. Just give it a chance, but nothing's really happened. Okay, it's all stable now, so maybe I can go back to my alignment idea. Do that. Let's take a look at the AVC. I should be able to pick the AVC up on the grids of these two front-end tubes. Either one of them should show it. So look at the 12BE6 coming off of... Maybe we'll do the... mumbling. Let's see if we can find this capacitor, this 0.01 capacitor. And it's connected, you know, it's connected right off of position 11 on the switch. 0.01 right off of position 11 on the switch. Yeah, where's position 11 on this switch? Once again, I don't fully understand the switching diagram they've shown here. Switch 1, section number 1, rear. A phono input is attached right near it, or at least on the same part. So let's trace that phono input. So, no, that's the antenna. Phono input is here. Comes around to here. Okay, so Now we're looking for a 0.01 capacitor. Oh, it could be. Wow, it could be that one way down the bottom there that I replaced early on when I was doing capacitors. I can't remember what I put in there. So 0.01 could easily look like that. And there he is down there. So that 0.01 was like the first capacitor I changed out. Connected to it, let's see, so one side, the other side. So one side that's connected to this 47K should carry the AVC voltage. So if I can find that point, I should be able to hook up my meter to it. So that point, well, it's the other side from the one that connects to the switch on the capacitor. The other side. So there's the connect. So that would be right where? Right here. And there's a slight negative voltage there. So I think I found the right spot to connect the meter. Let's do that. This will allow us to watch the AVC voltage. Okay, put this like this. Turn on my meter. Now, when you look at this meter here, this meter is showing the AVC voltage. And let's tune the radio and see if it really works. There you go. So you can see as you pick up things, very, very distinct swing. This is going to help me align this radio to it. Beautiful. So, certainly seems like a really strong AVC voltage being developed here. Of course, that voltage can be patted down and messed around with. What scale am I on? I'm on the 5 volt scale, so it's 5 volts full scale, and I'm reading, you know, in the 4 volt minus range, and that, you know, that sounds like the correct kind of voltage you want to put on a grid of these tubes. So, sounds good. It's pretty steady. It's moving around a bit. That movement can be everything from the power supply voltage, 120 volts, varying slightly. More likely, signal strength is varying slightly. Let's pull the antenna off. And there you can see the significant drop. Put it back on. Let's go on another band, and we'll tune by watching that meter. So what's there? Some noise. But clearly AVC is working well. I guess interestingly enough, I've never really thought of this, but the AVC voltage, when you're not receiving a signal, the AVC voltage is reduced, so the grid becomes less negative, becomes closer to zero. Well, you don't want a grid at zero, or the signal will drive the grid into a positive range and you'll start getting some distortions and stuff. So as the signal gets larger, the AC signal gets larger, the AVC voltage comes down, becomes more negative, giving more and more room on the grid for a larger signal to come in. So the smaller signal is kind of doing this thing. You can kind of get my graphic finger display here. I don't know if you can or not, but so anyway, that all seems to be working just fine. Lots of strange noises. All of them just interference type noises. Not much real radio stuff in there. And what I mean by that are signals coming from transmitters on purpose. Don't get nearly the AVC response on this is the high band, the high shortwave band.
We'd love to have you back on. Our guest, Dr. Monica. Sexuality and Authority in the Catholic Church. Up next, Dan Burke from National Catholic Register, of course, in the Avalanche.
I always kind of wonder how come I can tune all these religious stations on the radio here, but I never actually tune God in himself. I kind of wonder why he doesn't broadcast. He should have his own frequency. We can all go listen to him. But I'm afraid we have to settle for listening to human beings all the time. Okay, well, once again, it all seems to be working just fine. No noise, no hum, everything's steady. Oh my god. Well, let's give it full voltage here too, full supply voltage, because it's only running on 109. This will bump it up to like 120, so it's really gonna put it up near the top of its preferred operating range. Here we go. Ooh, a little higher yet, more like 120, probably 125 volts. So shouldn't hurt the radio, should be able to take it just fine. But it will raise the voltages of everything. So if there's anything here that wants to act up, now is the time. I mean, here's another effect I don't fully understand. So this is the ground to my signal generator. I'm not feeding a signal into, well, I am actually, but it's way off frequency. It's nowhere near what we're listening to. When I put this ground on, it quiets the radio. Why would that happen? I don't know, what am I doing? I'm shorting the antenna out? What's going on here? So, hey, there's that hum. Hey! Oh my gosh. Somebody help me. Here's what I just did. That's the... Help me, quickly. Send somebody to my house to help me, for crying out loud. Okay, this is the ground. I'm sorry, this is the negative lead to my vacuum tube voltmeter. It's connected directly to the B- point in the radio. And when I take it off, I get a big fat hum. Ah, okay, so here's the signal side of the meter. And where's this? This lead is connected to, this lead's connected to a lead that goes to the grids of the first two tubes. So you can expect that to be sensitive. So what's happening here? You know, I'm not sure I can explain this properly yet, because I'm still formulating exactly what's going on here, but it has a lot to do with the relative voltage to ground, I'm pretty sure, and the fact that this radio is not normally grounded. That's on an isolation transformer. So yeah, I don't know how to explain this properly. I do have something going on in my head here which explains it to me, but I can't really put it in words yet. So I'm not so surprised that... Oh, okay, wrong lead. Hold on. Everybody back up. We're getting somewhere now. Well, there could be all kinds of ground loop sort of stuff involved here too, where I have one instrument connected the, let's call it the hot lead of the instrument, and meanwhile I've got the ground of another instrument on the radio, and there can be a slight ground potential between these two instruments due to current flow on the ground wires. And in high sensitivity situations, like a grid on an early tube in a radio, these small voltages can show up. That's my story. Sticking with it. Let's carry on with what we're trying to do here, which is align this radio, hum and all. Is this going to throw the alignment process off? I don't really think so. Certainly it's throwing me off. I mean, all we're hearing is a hum here. On that radio. Oh yeah, I've got no antenna connected to it. Okay, no antenna. AVC voltage low. Gain is high in the radio. Let's put on a signal here. This might cause a big hum. No. Gets even quieter. I can't even guess what's going to happen next. Lordy be. I just trust if I just keep hammering away here and keep working on this thing that a light bulb will come on, hopefully inside my head, and it'll all make sense suddenly. And from then on I'll be in control of everything. Right now I feel like I'm out of control here. I don't feel like I'm out of control. I am out of control. I'm totally out of control. Let's do an alignment. It's all quiet and happy. Me too. Do I dare put the ground on from my signal generator? And let's dial the signal generator up in the range of the radio, which would be up around 12 to 13 megacycles. So let's. You can't quite see those numbers, can you? Shift the radio this way a bit. Okay, so you can see the numbers up here. And when you see my arm go up like this, I'm turning the dial just above here, just out of your view. And you keep your eye on the AVC voltage. And that's just the line voltage. That shouldn't really move much anymore. It should stay around the 125 mark. Okay, let's go for it here. What did I say? It was up around 12, I think. Oh boy, I'm gonna do a little maintenance on things here. Okay, we'll tune the radio. It's a better tuner anyway then. Now I'm watching the AVC voltage. So I'm tuned right on. Something's drifting slightly. I'm not using my best signal generator on this. So this signal generator is not, you know, it's lab quality, but it's kind of on the fringe, I'd say. It's like a cheap lab instrument here. from 19, I don't know what. Okay, pretty steady now. We'll give her a tune here. Okay, so I'm going to twiddle the IFs a little bit. This is not the right way to do it, but it is a way, it's valid. And I'm watching the AVC voltage. This one's at the end of its travel. Oh boy, feels like it's jammed in there now. There we go. So watch that meter very carefully. You can't because of my arm. There we are. Watch that meter. You know what I'm going to do? I'm going to give you a closer view of those meters, of that meter, because this is all about the meter. See if I get the signal generator and the meter together. It's a little tough. Equipment's a little spaced out, so keep your eye on the meter here. I'll try the top of that. Ooh. Just retune this. I don't like to do that, but I think I'm bumped it. Touch. This is why it's not the right. This is not the right way to do this. Really, you need to put in a IF frequency into the IF. Got a boost there. The other one now. Yeah, it's just, it doesn't want to turn. We're getting a pretty good boost out of this. This one's not, this one goes one way. Okay, I think that's about the best we're going to get out of the, look at it, everything's influencing that meter, my hand, everything. I think we got a little boost out of it though. I don't think there's much more to get out of the IF. I think that's... Sounds pretty good. Yeah, as I tune across, there's one clear peak, which is great. Okay, now let's go on to do, what band are we on anyway? Okay, we're at the highest band. Should tune it to 16 megacycles. C note C. Unscrew oscillator trimmers approximately 3 turns from tight. Then turn adjustment clockwise until first output peak is obtained. Make adjustments using this peak. Rock the tuning capacitor slowly back and forth while adjusting antenna trimmer. So, now often these instructions are actually written as if the radio is so far out of alignment that you haven't got a clue where you are. And that's of course not the case. These things come out of the factory aligned, and all they do is drift a little bit. So they're all close to being aligned. And if a radio is way out of alignment, there's something wrong with it. Or somebody twiddled all the stuff. I mean, that can happen too. Somebody get in and twiddle everything. I certainly did that when I was a kid, not knowing what I was doing. And, okay. So, we want to tune oscillator trimmer C12. So, if we're going to do that, we better align this it suggests we do it on 16, so I'll put it up to 16 here. Okay, so that would be 16. Pretty close, eh? 15.7. Let me make sure the pointer. Okay, so it's definitely set to 16. There's a scale on the front of the radio, even though the radio's out of the box. Oh, shit. There's a scale, piece of paper with a scale on it. So even though it's out of its cabinet, I can still tell where to dial it. So, where are we at now? We're listening to that signal. What's going on here? What was that jumping there? On, Jimmy. Okay, so where's the oscillator trimmer number 12? That could very well be C12. Okay, so C12. Nice diagram here. And it shows C12. Aligned to 16 megacycles. So let's get on C12. Uh-oh. Move the camera for a moment. Let's add some tools. Okay. Now, a little hard for me to see back here. That's the way I've got the radio here. Where'd the sound go? What happened? It's completely silent. Okay, loose speaker connection here. Hang on a second. I've just twisted these wires together by hand. They're not really connected properly. I didn't use clip leads or anything. I just twisted them here. So that's why they're acting up a little bit. Okay, I think I'm ready now. Put that down. What's in there? I can't see down in the hole to see what kind of connector it is. What kind of connector? What am I talking about? What kind of screw it is? So here we go. Okay, so this is the oscillator setting. What we're going to want to do is make this radio pick up 16 megacycles where it's tuned right now. There's a bit of a gain here where you have to chase the signal generator signal. So let me turn it up. I've already drifted it off there. Ah, my screwdriver has fallen off the screw. Okay. So we'll turn up the signal generator up one step, and then find it.
These footprints.
Where'd it go? There it is. Okay, so I know which way to go now. I'm turning the screw counterclockwise. Here we go. Kind of a hopscotch thing. Signal generator up. Radio up. Sorry about my arms being in the way here. 16. It's a hair trigger here. Excellent. Okay, so now when you dial this radio to 16 megacycles, you pick up 16 megacycles. And the next one is the antenna trimmer C5. C5 is in this bank here. Third one up from the back. 1, 2, 3. Turn it up again. Keeping your eye on the AVC voltage. Now I may not be able to do this with my metal screwdriver. Let's see. Yep, seems okay. Okay, I got the screwdriver engaged. I'm watching the meter. There we go, just... Oh. Oh, that was right on, wasn't it? So... That's it. My hand's having an influence, everything's having an influence here, so... But that was okay. So now we're going to go down one band, do the same thing, the next band down. Okay, this is done at 5 megacycles, so let's dial in 5, almost the same position for the capacitor here. There's 5, let's bring 5 up on the generator. Come on. Hey, what happened? Okay, something kind of funny happening here. Are we where we think we are? We're definitely on second band. Wow, is it that far out? We're putting out 4.4 right now. It's shooting for 5. Let's get it up closer to 5. Yeah, right past it. There it is. Very weak. So the first thing we want to do is bring that down to 5. So we have to adjust C14 is the trimmer most towards the front. That's right in here. Let's see if my screwdriver can do it. Now the reason I do these with a metal screwdriver, because everyone will tell you never do it with a metal screwdriver, is because of the problem with the plastic. Plastic screwdrivers bend and twist. And it can be very difficult to make precise adjustments with a sticky slug and a tool that twists and loads up a lot of spring energy inside itself. And when the slug moves, it jumps. It's very hard, so I like this solid metal deal here. Now here we go. What have we done here? Well, we want to get this to say 5. What have we done? What have I done? There we go. Okay, so trouble adjusting it. Well, I sure hope the RF brings this up because it is weak. 5065. I'm going to leave it there. Let's tune it better with the... can't tune it much better. It's really weak. And the other coil is antenna trimmer C4. C4 is the one at the back. I hope this picks it up a lot because wow, it's weak. There we go. I got my wish. Let's just tune slightly different because there's some terrible noise right there. It's pretty quiet there. Well, it's really getting a big AVC swing now. So I'd say we really picked it up on that band with the antenna trimmer. And next thing is the broadcast band. We go to 1600 kilocycles. Okay, let's do that. So so go down to AM band. 1600 kilocycles. This radio's working well, isn't it? It's not doing anything really terrible. There's no 1600 marked on here, but there's a 1500, so we'll do it at 1500. Hard time picking it up again. I'm not getting some funny stuff on this band. But we're not getting my signal generator. What's up? Something not quite right here. Well, I can't do anything like this. Well, let's just go mid-band and see, oh, that's interesting. You know, I've been doing this all this time without the signal generator actually plugged into the radio. Up until now, the signal that the radio's been picking up, it's been picking up off the antenna. And the signal generator is just playing into an open connector here. So that's another really good plus sign for the radio's sensitivity. But on AM it's not working so well. So I'm going to put this right into the signal generator. Okay, so now we got the signal generator putting a large signal into the front end of this radio. Bingo, there it is. Okay. Look at the AVC, it'll be maxing out. Look at it, look at it. It's slamming my meter. Whack. So we're really pumping a big signal in, so let's not do that. Okay, still driving the AVC right over, and this is not good. You do not want to do alignments with the AVC knocked way over like that. You really want the AVC pretty minimal, so we'll just turn this down. Keep turning it down. It's about as low as I can get it. So that's perfect. That's good for alignment right in there. Of course, you can hear many other signals coming through. What happened? What happened? Oh, this is quite the radio, isn't it? It's coming back. Here comes the AVC's coming up. Okay. Whoa, what's happening? Here's my hands. I'm touching nothing. I'm standing perfectly still here. Yeah. Okay. Excuse me. Now, yeah, I guess in real TV they edit out the sneezes, but Jim's TV, the sneeze stays in. Okay, lots of thumbs up today. Okay, let's see if we can figure out what is happening here. Now what I did there was I removed the lead that's bringing the generator signal into the radio. I'll remove it again. And you see the AVC voltage did not zero rate out. But during our little soundless event there, it did zero rate out. Okay, I'm not moving. I'm sitting here as still as I can. Look at that, eh? Okay, this could be everything from a clip lead. Could be the output of my signal generator. We're going to have to go through these things and kind of troubleshoot the setup, the test setup here. So let's start here. Chasing ghosts here. Now I check my clip leads quite regularly, so I don't normally suspect them, but these clip leads, they are often really crap. When you buy them in the package, these clip leads like this, often the wire connection is simply a mechanical crimp. There's no solder involved. And they give a lot of trouble, and you know, troublesome clip leads can make for disastrous work in a shop like this. Okay, I'm drinking my cold coffee here. Well, it's still wandering up and down. Pretty hard to do a alignment with it wandering up and down. Now we're on the AM band, so let's flip up to the next band up and see if the same thing is going on here. So I'm watching this meter very carefully now, and it's bound to fluctuate a little bit. I don't think that's the same. I don't think there's anything going on there. Let's go back to AM band. Well, I don't know what to make of it. Whatever it was, it's not here now. So let's carry on with the alignment. Just trusted some kind of wonky connection in my test setup. Okay, so we should do this alignment at 2 points on the band now, 1600 and 600. So first we'll go up to 1600. Oh right, it's not marked. Okay, that's 1500 in a very quiet spot. No. I have to crank this thing way up to we're at 1450. You know, that's close enough. That's close enough. I'm not gonna. Where'd you go? What the heck happened now? Because I just turned down my signal generator too low. I could actually hear the pointer of my meter slam against the upper stop when I did that. Well, I can't, okay, we're going to leave it where it is. Right. And what we really want to adjust is not so much the oscillator, in this case, just the intended trimmer C4. C4 is, hey, wait a minute. It's the same one. C3, I'm reading this wrong. C3. Second one in from the back. Gotta make sure I get the screwdriver into the. Okay, here we go. Watching the meter now, very carefully. Okay, so that was at its peak. And the other thing to check now is the other end of the band at 600, and we're supposed to adjust C16 for that. So let's go down to 600 and see if we're anywhere near it. Okay, that's 600. We're dialing down to 600 on the signal generator. Come on, where'd you go? There it is. Yeah, you know what? It's pretty much right on the money, and the only thing to adjust there is an oscillator pattern. We're gonna leave that because the AM band is pretty good. So what have we done here this morning? We double checked the IF tuning by tuning in a regular station and just peaking on a station. Got a little bit of a boost there. We did all the we did the oscillators, trimmers for the 2 shortwave bands. Or did I leave the second one alone too? Maybe I left the second oscillator alone. We did looked at the oscillator for the AM band, decided to leave it alone. At both adjustments, both trimmers. Got a big boost on the antenna trimmer for the, was it the middle shortwave band? I think so. One of them anyway. And not much else anywhere else, just a little improvement here and there. In the meantime, the radio's behavior has been, you know, maybe if I just put it in the cabinet, it'll feel at home again and work properly. So I think that's the next place for this radio, is into the cabinet, and then a fairly long period of testing, just playing it. Because I just don't see what more I can do. It seems to be behaving quite well now. It's a mysterious guy, isn't it? So why don't I do that? We'll finish it off. I'll put it in the cabinet, play it all day somewhere, see what happens.